Imagine trying to hail a cab, but instead of a car, you're hailing like a globally distributed supercomputer, and you expect it to arrive and start processing in under 5 seconds. Welcome to this week's deep dive update on the GPU and AI space. Today, our mission is to look at a massive growth milestone Nodexo hit this week and what it signals for the network's future.
Okay, let's unpack this. The team dropped a tweet that officially clocked the network crossing the 100 GPU mark.
Mm.
I mean, we are sitting at exactly 101 verified GPUs online right now.
Yeah, breaking that 100 node barrier is a huge psychological and physical milestone for any decentralized compute market. It really just proves the architecture can actually handle real world scaling.
Right, and the stat that really caught my eye is that these GPUs are rentable in literally a single command. It goes right back to that instantly hailing a cab user experience. But I do have to push back here a bit.
Okay, go for it. Well, we are talking about a fleet spanning 7 different GPU classes across 16 countries, right? Some are in massive data centers, but others might be, sitting in a garage rig somewhere. How does a decentralized network actually guarantee I'm getting the raw compute power I'm paying for? Like, how do we know it's not just some guy faking it on a dusty laptop?
Well, that is the core challenge of decentralized infrastructure, for sure. But the data from this week's update shows they are maintaining a 99.8% 24-hour reliability rate.
Wow, 99.8%.
Yeah, it's pretty staggering. And they manage that through continuous timed hardware challenges. Basically, the network is constantly firing off these complex cryptographic math problems to every single node.
Okay, so they have to solve them fast to stay on.
Exactly. A real, physical high-end GPU can crunch that specific math in milliseconds. But if a node tries to emulate that GPU using software, it will naturally lag.
Oh, I see. So it operates almost like a cryptographic reflex test?
That's a great way to put it, yeah.
So if you're pretending to be a top-tier machine, your software emulator takes a fraction of a second too long to process the math, and you just miss the time window. And then the network boots you.
Right. Physics literally prevents you from cheating. And what's fascinating here is how that physical verification mechanism ties directly into the economic engines outlined in the Nodexo white paper.
Oh, right. The economic side of it.
Yeah. By proving they can securely verify and route work to one-on-one GPUs, they are hitting the acceleration point for Metcalfe's law.
Right. So in a compute liquidity context, that means the value of the network is scaling with the square of its participants. Basically, liquidity begets liquidity.
Spot on. The more operators that plug their verified hardware into the network, well, the wider the selection becomes for developers renting that compute.
Which makes sense.
And that widened selection, combined with the 99.8% reliability, makes the platform incredibly attractive to new renters. When those new renters flood in, it deepens the overall demand, which then incentivizes even more operators to join. It's a total compounding loop.
So, what does this all mean for you listening right now? Why should you even care about 101 GPUs? Well, if you're building AI models, this milestone means you now have instant, frictionless access to a rapidly expanding, globally distributed pool of verified hardware.
Yeah, you don't need to jump through hoops for a corporate account or sign a long-term contract or anything like that. You just run a single command.
Right.
And as the development team noted in their update, they are really just getting started. Crossing 100 verified GPUs proves the peer-to-peer compute market is successfully scaling out of theory and into reality.
But wait, I have a thought on that. If we're scaling this successfully and making compute this frictionless to access, wouldn't we just run into, the highway expansion problem? Like adding an extra lane to a congested highway, it just attracts more traffic until it's jammed all over again. Does making compute easier to get actually solve the AI bottleneck, or does it just create a massive surge in new demand?
You are perfectly describing Jevons paradox, actually, which the white paper specifically highlights. Historically, when we make a resource drastically more efficient to use, like coal engines back in the 19th century, we don't actually end up using less of the resource.
We just build way more engines.
Exactly. We build way more.
That is an incredible concept to leave off on. If this network makes accessing trustless AI compute nearly invisible and totally frictionless, the ceiling for what we can build completely disappears, meaning the total global demand for computation might be about to skyrocket even further. Something for you to ponder as this network keeps expanding. Thank you so much for joining us on this deep dive. We'll catch you on the next update.